In this video, we'll discuss how to use chemical equations to convert quantities of gases. So in this example, methanol can be synthesized by the reaction carbon monoxide plus H2 yields methanol. What volume in liters of hydrogen gas at a temperature of 355 Kelvin and a pressure of 738 millimeters of mercury is needed to synthesize 35.7 grams of methanol? So we know that a chemical equation gives us ratios of moles. And here we have a 1 to 2 to 1 ratio for carbon monoxide to hydrogen gas to methanol. So our methanol to hydrogen gas is a 2 to 1 ratio of hydrogen gas to methanol. So if we find the moles of methanol, we can convert that to moles of hydrogen gas and then ultimately to volume of hydrogen gas. All right, so here's the way we're going to do this. Grams of methanol, which was given to moles of methanol, which we can use the molecular weight for. Moles of methanol to moles of hydrogen through the balanced equation where we have a 2 to 1 ratio. And then moles of hydrogen, we can use the ideal gas law equation to convert to volume of hydrogen. So let's get started. 35.7 grams of methanol is 1.1142 moles of methanol, and we get that through the molecular weight. So from the 1.1142 moles of methanol, we can use the balanced equation where we see we have a 2 to 1 ratio to get 2.2284 moles of hydrogen. Now we have the moles of hydrogen, so we can calculate the volume of hydrogen. The volume of hydrogen is related to the moles by the ideal gas law equation. The volume is equal to moles times RT over P. So in order to use this equation, we have to convert the pressure from millimeters of mercury to atmospheres. Okay, and when we do that, we can plug everything in. Now we have moles of hydrogen, we have our R, and the temperature is 355 Kelvin, and we have the pressure in atmospheres, so we calculate 66.9 liters. Next we'll work the 4 practice and 4 more practice problems. For practice 6.12 says, in the reaction shown here, 4.58 liters of O2 forms at P equals 745 millimeters of mercury, and T is 308 Kelvin. How many grams of silver oxide decomposed according to this reaction? 2 moles of silver oxide yields 4 moles of silver and 1 mole of oxygen gas. So we have a ratio of 1 to 2 for oxygen gas to silver oxide. So we were given enough information to calculate the moles of oxygen gas. So first we're going to calculate moles of oxygen gas. Second, we'll use the balanced equation to convert moles of oxygen to moles of silver oxide, and then we'll convert moles of silver oxide to moles to grams of silver oxide. All right, so let's go ahead and get started. First, we need to convert everything that we need for this calculation. So our pressure in atmospheres is equal to 745 millimeters of mercury, and 760 millimeters of mercury is 1 atmosphere. So our pressure in atmospheres is 0.980263 atmospheres, and that's for the O2 because we were given this information for O2. Okay, so this was here. All right, and we know that PV equals nRT, so N is equal to PV over RT, which is equal to 0.980263 atmospheres times, V, which is 4.58 liters, divided by 0.08206 liters, atmospheres per mole Kelvin, that's our gas law constant, times 308 Kelvin equals 0.177634 moles of O2. So we were given enough information here to find moles of O2. So now we can use the balanced equation to convert moles of O2 to moles of silver oxide. All right, so let's do that. So 0.177634 moles of O2, and we know that 1 mole of O2 yields or comes from 2 moles of Ag2O from the balanced equation. And we can go ahead and convert that straight to grams, which is what we were looking for if we know the molecular weight of silver oxide. So 1 mole of silver oxide is 231.8 grams. So that gives us 82.4 grams of silver oxide. Next, we'll work the 4 more practice problem. In the previous reaction, what mass of silver oxide in grams is required to form 388 milliliters of oxygen gas at pressure equals 734 millimeters of mercury and 25 degrees C? So our first step would be to find the moles of O2 from PV equals nRT. All right, and then we're going to use that information to convert moles of O2 to moles of Ag2O from the balanced equation, and then we're going to convert moles of Ag2O to grams of Ag2O. And so we learned from that balanced equation that 2 moles of silver oxide gives us 1 mole of oxygen. So we have a 2-to-1 ratio. All right, so let's convert everything. Our pressure is equal to 734 millimeters of mercury. And we know that 760 millimeters of mercury is 1 atmosphere, so that gives us 0.965789 atmospheres, and that was for oxygen. Next, we know our temperature in Kelvin is equal to 25.0 degrees C, all right, plus 273.15, which is equal to 298.15 Kelvin, and our volume is equal to 388 milliliters. Okay, and if we divide by 1,000, that's equal to 0.388 liters. Next, we can use the PV equals nRT equation. N moles of O2 is equal to PV over RT, so that's equal to 0.965789 atmospheres, all right, times 0.388 liters divided by 0.08206 liters atmospheres per mole Kelvin times 298.15 Kelvin. And that's equal to 0.0153161 moles of O2. And now we can convert moles of O2 to grams of O2 from the balanced equation and the molar mass. 0.015316 moles of O2. Let me clean that up a little bit. All right, and 2 moles of Ag2O results in 1 mole of O2 from the balanced equation. And we know that silver oxide is 231.8 grams per mole. And that equals 7.10 grams of silver oxide.